Hey guys, so I know it's been a minute. You're wrapping up and everything. I'm sure everybody has been busy with that, but now that I have a little more time, kind of going through and looking at some more, just different things that I've found and seen work well in my classroom, and both virtually and in person. And I think as even a lot of schools move back to in person in the fall, I think just because of the necessity we had this year of incorporating technology, I think a lot of schools are going to continue to move toward that. Maybe your district has added to their Chromebook fleet or their iPads, or maybe a lot of your kids have got their own devices now. So I think some of these tools in the virtual world are here to stay, and I think it's a good thing, because I think for some students this may be the avenue that works best for them. So today I'm going to talk about PhET Sims, PhET Simulator. They are some great tools that I think a lot of us know about already and may have used, for several years. I remember first seeing. I feel like they were around when I was first in high school, and definitely I saw some of these. And looking back at some of the older Sims, you can tell that they've been around a while before they revamped them. So today I'm just going to mainly focus on the physics side, and then I'm going to do another one with some of the chemistry ones. The physics ones have been around for a long time. A lot of them have been redone. There's now HTML5 versions, which are great because they work on pretty much anything. So just kind of going to dive into that, give you a little overview of PhET if you're not familiar. If you've used them before but didn't have a great experience, I'll try to kind of give my my take on it. So this is just a look at what PhET has to offer our physical science students who are kind of getting that intro to the physics concepts, the motion, the energy, that kind of stuff, and then what it has to offer our physics kids as well. And some, there's some of the material even scaled toward the college student who needs to review some concepts. After all, PhET is created by the University of Colorado in Boulder, and they kind of house all these simulations and use them in some of their collegiate physics courses. So just an overview, we're going to talk about why they're fantastic to use, just some general facts about them if you weren't familiar, some of the ancillary materials that come with, and then some of my favorites as well. So why PhET Sims? So PhET Sims are great because they work on everything. Now, with that being said, there are some of the older Sims that may have specifically just been Java-based, and those some of those use another like third-party thing to help them run called JChirp, I believe, or Chirp J or something. But they are all able to run. Some of those older ones that are Java-based may not work on, like, say, an iPad, even with that plugin, but they will still, can still be used on a computer, and of course be downloaded in a lot of cases as well. So next, there's a huge library of Sims. Even the HTML5 stuff has really grown a lot in the past couple years as they've converted and recreated and kind of retooled some of the things they originally had. It's great because it applies to all levels, from your kids who may be in a resource physical science class, where they just need that support, and they need to get the material kind of in multiple ways to help them build that understanding, to those upper level physics, and even into like an AP physics type kid who might need some review or remediation, or just something to kind of jumpstart their learning, or some type of activity that just is a little more inquiry based, where they can kind of make it their own and work toward some of those type goals that we typically have for our learners. And then, of course, the great thing about PhET Sims is it's free. It's all donation based. It's funded by several, larger science communities, and it is updated pretty frequently. It seems like most of their material now, uh, their older stuff has been redone or updated, and most things run very well. Um, I've, of course, had students in the past who their goal after they got done with their work was to see if they could crash the simulator, and most of the time they were unsuccessful. So there is that as well. All right. So let's look at a few facts related to it, and then I want to jump and kind of bounce back and forth between the PhET website and the slides. There's really not a lot of slides in this presentation because I more want to take you through just some of the PhET things they have available, and then some of the ones I've used before in class that are, in some cases, pretty simple, but do a really good job of demonstrating things in scenarios where I may have not had the actual physical resource, or a situation like this year where kids were not in the building and I knew they wouldn't have a particular resource at home. It kind of allowed us to still do a lot of those same things. So just some facts about it. Of course, it's a free resource. It's all done by the University of Colorado Boulder, so it's great that they have this out there, and basically just give it to teachers to use, which is awesome. A lot of the sims have been converted to HTML5, so there's not many issues running them on different devices. Now, like I said, some of the original versions might still be Java, and so that may limit you a little bit. Obviously, Java doesn't run, or Flash Player doesn't work anymore. So there are some plugins, kind of third-party things that help those run that they have used and incorporated in their website to help you out. It's nice because you can run these fully online, so they can be on something that doesn't have, a hard drive or a lot of storage space, or they can be downloaded. So if it is a situation like, I know, in the past, if you had maybe the Wi-Fi go out or something, or your internet access out, if you download it, you could at least as a teacher run it up front for the kids and still be able to get some of your lesson in, which is nice. Of course, you'd have to plan ahead there. It obviously has a ton of physics. That's where it kind of started. And then, of course, naturally kind of overlapped into chemistry, with it being a physical science as well, and math. And they're even now adding a lot of earth science and biology as well. I'm not as familiar with those. Some of the math I am familiar with because there's some overlap with physics and chemistry, of course. But earth science and biology, not as familiar with, but there are resources out there. And there's well over 100 available to use. I think the physics HTML5 numbers like up in the 40s. Chemistry's, I want to say, like in the 30s. Then you have math and earth science and biology up there as well. And that's just the HTML5 stuff. There's even more other things out there as well. So let's look here just kind of at some of our PhET stuff. So if you just go to the main website, this is what you'll see. They have all kind of different stuff here. There's some, just areas for you to kind of look at different things if you're not familiar at all. Of course, you have the simulations, the main deal there. You can browse them. You can also, a lot of times I'll have kids just type in Google, like, moving man simulation, and it pulls it right up. So a lot of times that's kind of the easiest way. They're easy to search. They're easy to pull up, which, that's huge when you're in a classroom to keep kids on the right path in their learning. So, they have some about stuff and some short videos if you want to take a look just to get a better idea of what's going on. But like, the people in the picture here, they're in a college course using some of these simulators. So they really can be tailored to whatever you need them to be for your classroom. So next, I want to talk a little bit about, so then they have some other accessibility information. Here's kind of all the simulations at once. And then you can jump in, and if you're searching for something specific, like right now I picked physics, so all the physics ones are clicked. If I just wanted to look at motion, I could go back and just look at motion and pull those up. Right now I only have HTML5 clicks, so it's only showing me about 15, but if I want to pull any of all the ones that have been created up, I can do that. Now, some of them you may have trouble running depending on what you're on. A lot of them they've revamped and made an HTML5 version that's comparable. So there's those as well. So yeah, so if I click back on HTML5, and then you have all your physics stuff here, and then of course you have chemistry and math, and now even earth science and biology. So several to choose from. Earth science and biology doesn't look like there's a ton there yet, but definitely plenty of physics and chemistry. And you will see kind of as you go through, if you notice, if you look at each category, it's going to add up to more. And that's because, they're going to have things in both categories, physics and so like gases or gas properties might be also in the physics tab. So just kind of be aware of that. You might see some overlap, which is not a big deal because obviously chemistry and physics have some overlap. So let's look back at our slides and talk a little bit about the next awesome thing, which is our ancillary materials. So the cool part about it is it's not just the simulations. They have uploaded, and I say they, a lot of it's from PhET, some of it's from other teachers who use the platform. It's kind of all over the place. Some I've even gone through and seen, they might have a Spanish version of something. So if you have a student who needs that support, that might be there as well. But they have lesson plan ideas from educators. Some are people employed by the University of Colorado at Boulder. Some are just other educators out there that have put their lesson plans up. They also have pre-made student handouts. Some of those are PDF versions, so you can download them and use there's various out there now, PDF editor to change those up. A lot of them have Word options as well. And so obviously the Word options, you can download those, edit them right away. You can reduce assignments, you can combine assignments. It's really not that difficult with a little bit of work on the, on Word or putting it into a Google Doc and things like that. There's also, in a lot of cases, a key that the teacher has posted. So you can kind of, if it's a topic you're less familiar with, it might help you kind of get an idea of what they were looking for kids to do in this scenario. Or if you just didn't have time to go through it completely on your own and create your own key, you might have the need to use one of theirs. So let me show you where those are really quick in just one of our examples. So this is the moving man PhET, and I'm going to talk about it in a little bit. Let's look at this one. So when you pull up a page for the specific simulation, it's going to look like this. Some nice parts about this is we use Classroom in my district, so I can throw this right in the classroom if I want to, make it an assignment pretty simply. I'm not going to open Classroom up. But that's nice. You can embed it. You can download it, right? So you can download it for use offline. Some of the ones like this one is a convert from the original Java, but it's been converted to HTML5. The ones that haven't been converted, they look a little different. They look like this one. Kind of looks like an old window within the page, and that that app to convert it is contained within PhET, so you don't have to like download something else. It just moves through it automatically. It does just take a little bit longer. If we have some time, I'll show you kind of what it looks like that's different, but these things open up really quick, which I'll show you in a minute. But this is the For Teacher tab. Now for this stuff, some of it you cannot download unless you have an account. Now your account is here, and to get into your account, which I don't think I have on this one yet, to get into your account, you just type in to create an account. It's just your school email and a password, and they just verify that. And let me go to the one I'm already logged in on. Maybe or not. So within this, you can still see everything. You just can't download them. Within this, they have not only people who are associated with PhET that created them, and you'll see this name a lot, but they also have just other teachers who have created material. They've marked it middle or high school. Some of them have even marked it, K through 5 if it even has some elementary application. So these are nice just because you can see kind of what others have done. They tag it as a lab, or maybe it's homework, or maybe it's an intro. And these have really grown, the number of these, obviously, because this past year, a lot of people were creating some online stuff. But typically when you open one up, it's not just one file. It's, I've got a couple docs, so we've got some tips for teachers. We've got some specific stuff. This one has a PowerPoint that goes with it. So there's definitely a lot of material here for you to use to where you don't have to just create everything on your own. And then, of course, a lot of us like to make things our own. So you have the ability to do some editing and create your own there. And I'll give you some instances of that when I go through each one. So this is really nice to have because you can, you can open these up and have some material to go off of, or just use their material if you really like it. I know for me personally, just looking through, I would always find like an author that I really liked, and obviously it was someone who used like multiple ones. And I think my first or second year, when I was just kind of trying to develop my course and build some material into it and all those kind of things. When I was first teaching physical science, it was a huge help to find somebody who really had created some quality material. And then I could also just pick that person as I went through it. It really helped me kind of get things started in a time where, I didn't have time to create material for every single thing that I taught. So I had this to use, which was great. And again, these are free. You just have to create an account, which is free. And just so they can verify that you're a teacher, so they're not just giving all the material out. So a kid couldn't get on here, I guess, and download and kind of have all the answers or something of that nature. So let's look back here. We're going to talk a little bit about some of my favorites. So I've used obviously more than 3 of the physics ones, but these are some of my favorites. Some of them may seem really simple to you, but I think most of us know that we have times where we need something simplified. And the nice part about it is, whereas maybe in a physical science classroom, you use this as a main focus, you could then go back in physics and use it to introduce or allow students to do a little bit of their own self-discovery within a lesson, which is great. So the first one I'm going to talk about is moving man. It's one-dimensional motion concepts. I really like it because a lot of students, when you start talking about one-dimensional motion, the positive and negative, that vector understanding of forward and back and those kind of things gives them a little bit of confusion. They also really struggle with motion graphs. In my experience, not just at the physical science level, but at the physics level as well. So those graphing velocity and acceleration concepts, and how a velocity or a position versus time graph looks different than a velocity versus time graph is definitely a struggle. So this one I really like for that reason. So let's take a look at it. Now, this one is one that had to be converted from, like when I first was looking it up, um, it's a PhET original lab, so it's Java based. Um, so this is the part of it I really like. So this has the chart for position versus time, velocity versus time, and acceleration, and I really enjoy it because they can compare what's going on. So you could give them a scenario where the man, and it's going to go all crazy as I move the guy around. Um, so you could give them a situation where the man starts at the tree. If I didn't want to move him over to the tree, I could just plug in -8. That's his starting position. And it could be create a graph of the man moving constantly toward the house. So I'll give him some positive velocity. I always encourage my kids to keep it pretty low. Otherwise, they're going to have to start and stop it within milliseconds of each other. So this way we have this graph being created. And the nice part, of course, is that the graphs are right there on top of each other. So they can literally look at 2 seconds, look at 4 seconds, look at 6 seconds and compare them, which is really nice. So we have, in the top one, you've got their position, it's getting close to 0, and then it continues on. And of course, there's that correlation between the position having a line that, with no curve, a linear line. And then, of course, the velocity staying constant as it moves across. So you can compare these right on top of each other, so students can see, okay, a position graph when the person's moving constantly, we're going to see this slope that's just not changing. We're going to see a straight line for velocity because the velocity is not changing. You could also give them a scenario, and say the man moves toward the house. When he's 2 meters away from the house, he stops and drops his keys. So now I could change my velocity to 0. And then they say, after 2 seconds, the man has picked up his keys and he starts to move again. So I can pause it. I can change my velocity back to 2, or not 6. Yeah, 2. And then he continues to the house, and I can stop it at the house. So then, like what I did in my lesson is I had them take screenshots of their graphs they created. Or, for my physics kids, I might have them say, or tell them to graph what it would look like, and then use this to check it, and then show their original graph, and then a screenshot of their graph they created on the app. So it really is a useful tool, in my opinion, especially helping them with motion graphs, which they really do struggle with, from what I've seen. So there's this piece as well. I also like it. Obviously, you can make them go backwards. So if I want to start them with a velocity of, say, -1, position, we'll make it 8. And then if I want them to speed up as they approach the tree, so the kids have to think, okay, they're speeding up, so this has to be, some acceleration, but they're going toward the tree, so that has to be negative. So then they plug in their value and then press play and see if it does what they, had intended for it to do. You will see, sometimes you have to change the scale of the graph as well. So like this one, a lot of the kids will be like, oh, it's at 0 the whole time for acceleration. Well, no, it's just the scale's a little bit off. So zoom in a little and you'll see that it's really at -2, like you put it. And then, of course, they can adjust. Usually these position velocity ones aren't bad. The acceleration one at times, though, can get kind of messed up. So, and then here they can see how that curve, obviously if there's some acceleration, we're going to see a curve in that position line. If there's an acceleration, we're going to see a change in that velocity line. It's just not going to be flat all the way across. So they can compare those differences that we're talking about, and, do something, kind of to go with maybe like a ticker tape type lab or something of that nature, where they're looking at how these graphs relate, which again is a struggle for some. So there's all kind of different scenarios you can give them. You can have them do their own, and then check it with this. You can say, hey, this is the scenario. Show me what the graph would look like. And they can pause and change their velocity and change their position. If they wanted him to slow down as he got toward the tree and, moving constantly originally, then he could be, his position could be negative or, slow down toward the house. We already got him over here. His velocity could be like 3 and then no acceleration to start. And then maybe it says slows down to reach the house. Well, then I could, I left my acceleration negative. Didn't realize that. Well, let's try that again. So my velocity, 3, acceleration is 0. There you go. And so then, it says moving constantly and then slows down as he reaches the house. So students can kind of start guesstimating okay, how much does he need to slow down as he reaches the house? So if I put in -1, he's probably, not going to reach it. And so then the kids kind of have to play with, so here I put in -1 and now he's barely going to reach the house. So they might have to adjust what values they put in to get them to do that. But really what we're trying to get them to do is create these graphs so they can see how that relates. Okay, here where I start to see that curve flatten out, I also see the velocity dip down and head towards 0. So that's really what it's useful for. All right, so the next one to look at is, hello, there it goes. Not thanks. Is Energy Skate Park. This is a pretty good one. The kids have a lot of fun with it too because they can there's a playground one where they can just kind of play around and understand these concepts. So this is really nice for kinetic potential, all that, mechanical energy, and then thermal energy as well. So we can peek at that one really quick. So this one is HTML5, so it's going to look a little different. It's going to load pretty quick. It might take a little longer because I'm screencasting, but it might be that as well. So definitely took a little longer with that. So there's always an intro for most of their things where you can kind of click on that to get started. I like this one because you can again pull a graph. So you can put the person on this one and it creates this graph that you can stop. So here, they can see, okay, the total energy didn't change. Thermal energy was 0 because we turned friction off. So obviously it's just going to keep going. And here's our potential that was high and our kinetic that was low, and then vice versa here in the middle. So they can compare those and look at those values. On a pretty simple track, they can change it to this one as well. And they can move these around on this so they can kind of create their own deal so they can see, make sure that's lower. So they can see how the graph's going to change in comparison. So here, we had those 2 points or 3 points that were high in potential energy because they were pretty tall off the ground there. And then these points that were very high in kinetic energy. So you have that as well. So high kinetic, low potential, or low kinetic here in the middle, and then high kinetic again. So, and then of course thermal at 0. And then if you put friction on, she's going to not make it over the hump there. And then as it goes back and forth, they can also kind of see that the total energy isn't changing, but we just have a ton that's thermal now, and then our potential kinetics just not making up very much. So they can also see how that friction relates as well. And they do have the option to look at the graph when you go into the playground one. So the playground one, the kids always like to make loops, which let me start from here. So a lot of times I have to kind of show them how the tracks work and function a little bit to get them started. Even the physics kids just, sometimes it blows their minds as much as they're on their devices. Stuff like this, they're not typically doing on their devices, so it can be a little confusing for them. Yeah, so a lot of them like to make a little loop here. I'm gonna have to move mine over. And then, of course, they can still compare kinetic potential. It's just it's just a different representation. They got these little bar graphs on the side here. And then I always like to make them jump off. So like she's going to fly off the track at the end and stuff like that. But they can still see that even when she goes off the track, that total energy doesn't change. And she just gains a lot of potential. She goes up in the air. So they can still see that potential kinetic. They can change the skater up to, ones that have a different, just using a different skater. They can change the mass of the skater, make it 100, see how that changes energy, make it 5, see how that changes it. So they can measure stuff and all those kind of things. This one, it just goes through and has a time on it there. They can get the speed to show up in a little thing there. They can have a pie chart that has the potential and kinetic. Oh, sorry. So the little pie chart, as it goes with a person, it shows what's more potential, kinetic, and it goes back and forth. So you kind of have that. If you miss the pie chart, there it is, and it just changes as they go. So like here, we're getting to the point where it's half potential, half kinetic, and then here it's more potential because we're higher, a lot of kinetic here, and those kind of things. So it's pretty fun for them to play with for sure. And they also get to learn a little bit about energy. And they typically seem to enjoy this one pretty well. And they obviously have different things you can kind of look at as you go through. All right. And so now the last one, which is motion and force. These are probably the ones I've used the most out of all of them. They're pretty simple to run, pretty simple for kids to understand. So this one, motion and force. So the motion and force, it looks at everything from net force to friction. It's a good way to review or introduce forces acting on an object. And you can look at, there's kind of several different options when we get in there, and you'll see that. Now this is the one that is going to be force and motion. I think this is the basics one. No, hold on. I think this is the original that they had to re-download. So yeah, so that was loading up the one, but we can go find forces in motion. So here's forces in motion basics. That's the HTML5 version. The older version, which is forces in motion, is not HTML5, so sometimes it takes a little longer to load. That's what it was doing. But what I need to show you is, or what I was going to show you isn't on that one anyway. And I have found for me, because I have used these for a little while, I have some older material that I had to use before HTML5 started becoming a thing as far as they converted them to them. So I'd have to, a few years ago, I'd have to schedule like a computer lab for a few of these. But now I don't have to do that. They can do it in the classroom, Chromebooks, on their own devices. Cell phones aren't great for them just because they will run, but it's just small, so sometimes that's difficult. But they will work on there. And I say small, a lot of the kids now, the phone screens are getting bigger and bigger, so it's almost like they're an iPad at this point. So here's kind of the 4 basic ones. So we have a very basic, just like tug of war. You can have it show values or not. What I like to do is have them, because a lot of kids don't understand the concept that forces can be balanced, but motion can still occur. They always think it just has to be at rest. So obviously, right now I have this one person pulling on it. So I'd ask the kids maybe like, what direction is this going to move? And they would all say to the left because nothing's pulling on the right. So then I would pause it after it's moving for a little bit. And I'd say, okay, I'm going to add this person. And I would say, okay, what direction is this going to move? And they would say, oh, trick question. It's not going to move. Well, that's not the case, right? Even though the forces are balanced, the motion is still to the left because that's the direction it was originally moving. And now the forces are balanced, but there's still motion. So it's a good, if I don't want to do a lab with it, it's a great like opener just to start some conversation, because a lot of the kids, they're like, oh, that's not real, or that's not what happens. And then they think about what a balanced force is, and those kind of things. And so then you can obviously add more people, and sometimes it doesn't. So here it slows down and now it starts going that direction. And they can see how it's accelerating that direction. And then, of course, the red team wins because they're pulling against one guy. So that's nice for net force. And, of course, most, you can pull in your force diagrams and things of that nature. And then this one is some stuff with motion. You can make the mass greater. They can compare, okay, I want to apply a force of 100 newtons, and we're going to see, we're going to compare the speed to if I apply a force of 100 newtons now at 50. They can also try to figure out what the mass of the box is based on the other information that they have. So they can put the mass of the box on there. They can change their force to, 500. And they can use F equals MA to figure out, what that box is. So again, there's opportunities to make it a little more difficult, or, opportunities for them to, and then of course I can stop it and see what it takes to stop it. And then there you go. Then there's one with friction. So here it's the same thing, and I can just increase or reduce friction. So it changes the surface from ice to like sandpaper looking, I guess. So then it just shows how they have to overcome that frictional force before they're able to move it. So if you have like the box is stopped, and then here you got to overcome that frictional force to get it moving, and they can kind of look at, okay, at what point, and then of course if they go below that, it's going to start slowing down again. So definitely some options here for you to look at. And like I said before, the awesome part with these is that you have those teacher resources there. So you've got those to kind of help you out. Some of them have videos that come with them, which are nice. Some of them have videos within their little assignment. But like this one, it has K5 all the way to high school, so different levels. This one's designed as a lab. This is my remote lab. This is guided versus inquiry based. This is, you got some that are homework and some that are demos, and so it's nice to kind of have a little bit of information. And like I said, you go through, and sometimes you'll find, oh, I really like Scott Clemens, so I'm going to see what else he has and kind of take an eye out for his name. I don't know if there's a way you can search for their name. If you have that question, I just kind of had it myself. I'm usually just on the lookout for a couple. So if you know how to do that, you're welcome to let me know. I'd love to share that with y'all. But that's going to kind of wrap it up for PhET and physics. So thanks again for tuning in. I appreciate it. I will be shortly dropping one for the chemistry side. I've used less of the chemistry stuff just because it just hadn't been out there as long, but I do still have some of my favorites in there. There's a couple good ones, especially for like phase changes and stuff like that. So I will speak a little bit about those on the next one. So stay tuned for part 2 of PhET, and I appreciate you guys checking it out today. Y'all have a good one.